Hey guys, Mr. Milton here. Today we're going to talk about scientific notation. At the end of this video, you should be able to write a number in scientific notation, order numbers written in scientific notation, and multiply numbers in scientific notation. Alright, so scientific notation is a way of writing numbers that are either very large or very small. Okay, our rules for scientific notation is a times 10 to the n, where a is greater than or equal to 1 and less than 10. So as we're looking at this rule and its application, how it would look when we write a number in scientific notation, it says which of the following numbers is written in scientific notation. Alright, so looking at that rule, a has to be greater than or equal to 1 or less than 10 and less than 10. So first option's out of there, can't be that because 52 is greater than 10. 3.46 falls into that area that it works because it's greater than, equal to 1 and less than 10. 0.04 is not greater than 1, so C cannot work. And then D looks like it can work, but notice that for D it's addition, and so scientific notation deals with multiplication only. Okay, so B is the only one that is written in scientific notation. Alright, so let's look at writing a number in scientific notation. It says write this number in scientific notation. What is that? Hundreds, thousands, millions, billions. Okay, so 5,700,000,000 in scientific notation. So here's our thought process. This is how we're going to go through it. So we'll go through the thought process and then we'll write the answer. So is this a big number or small number? Well, this is a big number. Billion. Okay, or large number. Okay. Where is the decimal currently located? Okay, if it's a whole number, the decimal is located at the end. Okay. Where should it be located? Okay. Because of our rule that a has to be greater than or equal to 1 and less than 10, then there's only one spot where our decimal can be located and that to be true. Okay, in this case, our decimal has to be located here. If it's located one space to the right, that's 57, it's greater than 10. If it's located one space to the left, that's 0.57, that's less than 1. So 5.7 is the only place that we can put our decimal so that it works with our rule for scientific notation. Okay, and so now we have to ask, how many places does the decimal need to move? Well, this decimal needs to move 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. It needs to move 9 spaces. This is my exponent. Okay, is this a big number or small number? In this case, it's a big number. I think we've already answered that. Okay, big means that it's going to be a positive exponent. Small number means that it is a negative exponent. Okay, so as we've answered and gone through this thought process, we said there's only one place where a decimal can go, 5.7 times 10 to the 9. Okay, and that's 5,700,000,000 in scientific notation. Okay. Alright, example 2 says write this number in scientific notation. If you would, pause it and then see your answer. See if your answer matches up with mine. Give you a second to pause it. Okay, so should have had something like 3.1. Let's see how many spaces. 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7, since it's a small number, negative 7. Alright, so writing a number in standard notation. So scientific notation is when we use the decimal. Standard notation is how we typically write it. from scientific notation. So it says write 5.21 times 10 to the fourth in decimal form. Okay, so here's our thought process. The exponent is a positive number. So this is a large number, or big number. And I move the decimal to the right. Okay. So I'm going to move this to the right 4 spaces. 1, 2, actually I'm going to move it over here. 5.21. So I'm going to move it 1, 2, 3, 4. Okay, there's my decimal. Now, every space that I have empty, I'm going to put zeros there. And so what I have now is 52100. Put my commas if I'd like. 52,100, so it's easier to read. Okay, if the exponent were negative, everything would be switched. It would be a small number, and I move the decimal to the left. Notice that moving the decimals to the left and the right does not change whether the number is positive or negative. It changes whether the number is a large number or a small number. Okay. Again, take this time, write this out in decimal form. All right. So that's what you should have for that. All right. So, ordering numbers in scientific notation. To order numbers in scientific notation, you must first make sure all the numbers are in scientific notation. It really wouldn't matter. I guess you could put them all in standard notation, but it would be, I guess scientific. Okay. You could put them all in standard notation, but when you're dealing with large numbers or very small numbers, that could be very time consuming. So it's best to put it in scientific notation. Alright. Alright, so once in scientific notation, look at the exponents first. And what that will do is it'll tell you where the bigger and smaller numbers are based off of those exponents. You can tell that a little bit easier than looking at the first term, since the first term really doesn't mean very much in the sense of greater and smaller. Here. So, it says if they are the same, the tiebreaker is the A value. So we'll look at the A value for tiebreaker only. So here it says order these atomic particles in lightest to heaviest. It's always important when they're telling us to order for us to know what they want to see first. Do they want to see the heaviest things first or the lightest things first? In this case, they want to see the lightest things. So when it says lightest, that really for us means the smaller numbers. They want smaller numbers and to the bigger numbers, so small to large. So we'll notice here as we look through neutron, electron, and proton that our proton is given to us, but it's not in scientific notation. So we'll want to put it in scientific notation before we think about it. Okay, the decimal needs to be between this 1 and 6. And so we move the decimal. I always like to think of these exponents telling me to do something. Helps me to change them. So at this moment, this exponent is saying, move left 25 times, move left 25 times. Okay, but if I see that I need to put this in scientific notation before I really see it as scientific notation. So this was telling me move left 25 times. I had to move left in order to put it where it was supposed to be. So what will this tell me now? Say, okay, move left 24 times, because I already did once in the direction that it told me to. Okay? So since I'm making the A value since I'm making the A value move by 1, I'll say decrease. Let's say decrease instead. Since I'm making the a value decrease by 1, not really decreasing it by 1, I need to make the exponent increase by 1 to keep it balanced. Okay, I like the explanation of following the directions of the exponent as well. So now I can look at this and I can say, okay, what is the lightest? Well, easily the smallest number is the electron. Okay, because it has a negative 28 as its exponent, where the other two have negative 24. And now I need to look at this tiebreaker: 1, 6, 7, 2, 4, 2, 4, 2, 4. Okay, so which one's going to be the lighter one? The neutron is going to be the lighter one because it's 2 instead of 4. So electron, neutron, and then proton. Okay. Okay. Multiplying with scientific notation. First case. There are more cases to come in later lessons, so we'll just look at one kind of example here, really. All right, so here it says multiply 12 times 9.1 times 10 to the negative 7th and write your answer in scientific notation. All right, so big thing here, big idea, this is not a distributive property problem. Okay, distributive property, if you'll remember, deals with addition or subtraction in these parentheses here. This is just multiplication. 12 times 9.1 times 10 to the negative 7. So in a problem like if we had, let's say, 3 times 2 times 7, it really wouldn't matter what order we multiply these by. If I do 3 times 7, that's 21. Times 2, that's 42. If I did 3 times 2, it's 6. 6 times 7 would be 42. 2 times 14 is, 2 times 7 is 14. 14 times 3 is 42. So notice that no matter what order I take these in, it's going to give me 42 because it's all multiplication. That's the case here. This is all just multiplication. And so we can reorder this in any way so that it's the most helpful to us. The most helpful thing for us to do is to not have to worry about this really small number until the very end. And really, not at all if we're writing our answer in scientific notation. So, I'm going to say, let's just multiply these two numbers. 12 times 9.1. Should be something like 108, 109 point something, but we'll look at it. 12 times 9.1, 109.2. So 12 times 9.1 is 109.2 times 10 to the negative 7th. Okay, again, we'll want to make sure that we have our answer in scientific notation when we're done, because our directions tell us to do so, but we're in a pretty good spot here. Alright, so now I'm going to move this decimal over to where it belongs. 1, 2, so it's 1.092. Please do not get rid of any of these numbers. You can't get rid of the numbers and say, well, I thought I was only supposed to write 2 numbers because only 2 real numbers are written. Keep all the numbers that you have. Those are significant figures. More of a science term than a math term, but keep them. And now we have to think about this exponent. Okay. At the beginning of this problem, this exponent was saying, move left 7 times, move left 7 times. So we moved left once, twice. What will it be saying now? Well, we did what it said. We moved left. We only did it twice, so it's going to say, okay, now move left 5 more times. And that'll be our actual number. So 1.092 times 10 to the negative 5th. All right. Okay. Last problem, another example of this. Again, remember that we're just going to regroup this so that we can do what's best for, I guess, efficiency in this problem. So we have 0.5 times 1.2. So 0.5 times 1.2, that should give us 0.6. I'll do it on the calculator. That's 1.2, it's 0.6. So I multiply these two together, I get 0.6 times 10 to the 8th. Okay. This is not in scientific notation because 0.6 is not greater than or equal to 1 and less than 10. It's less than 1. So I need to move this over one spot. So 6 times 10 to the... Now this was saying move right 8 times. I moved right once. So what is it going to tell me now? Okay, you got to do it 7 more times. Okay, so 6 times 10 to the 7th. Okay, I know it's kind of weird to think about that exponent telling you what to do, but I found that to be the easiest way to alter that exponent. If you try to think of it as, well, when you do a negative and you move to the left and you have to, it gets less about understanding what you're supposed to do and more about memorizing something. And I'd rather you understand how these numbers are changing or why you're doing what you're doing here. Okay? Alright, so that's scientific notation, multiplying with scientific notation, converting from scientific notation to standard form, and standard form to scientific notation. See ya.